Here's the first soldering test of soldering a plug into a brass disc. I used a type of flux that I've had good results with on a lot of electrical soldering. This is ordinary 6040 lead tin electronic solder. In fact, it's Radio Shack brand, some that I've had for a long time. So I have an excess of solder on there right now, obviously, but I'm going to try putting it in the lathe and turning off the excess and seeing how that comes out. I just finished soldering the plug into the gear, and I've got it set up here on the PM1228 lathe. I'm getting ready to turn it to clear off the excess solder. I forgot to do a video of the actual soldering operation, but it's pretty basic. This gear is so small, it's smaller in diameter than a dime, so the work could be done on the mini lathe, but I'm doing it here on the larger lathe because I want to take advantage of my lathe cams, which give me the ability to see a highly magnified view of the cutting action while I'm actually working on it. This is the view of the part from the normal lathe operator's position. For facing, I really can't see the part at all, or at least the area that I need to be able to see in order to do the work accurately. When I'm working, I'll actually be looking up here on the lathe cam. You can see it's highly magnified, so it really makes it a lot easier for me to trim away this thin layer of solder here. And I want to do that without taking any material, or at least maybe very little material, off of the face of the gear itself. I'm using a carbide insert tool. I got a set on Amazon that I like very well. For many years I used only high-speed steel, but these new carbide tools have been great. And the prices are pretty reasonable for the inserts and for the tooling itself. I'm going to switch to the vertically mounted lathe cam so I can see to touch off against the work. I want to get very close, but without actually touching the surface of the brass gear. Out a little bit now, see if I can pick up any solder. Well, I moved the camera and the gear over to the mini mill table just so I can get a better look at it. And this is the side that has not been turned yet or faced, and this is the side that we just faced. Now, one thing I can see now that wasn't apparent to me until I did this operation is that when I put this plug in, I was just holding it in place with some tweezers while I soldered it, and it's actually shifted farther to the back than to the front, so it's not perfectly lined up with the teeth. But I think what I'm going to do is just leave it and face it down, and I think it will be close enough. So it'll be on the back side, well, I guess what I think of as the back side. It will be almost perfectly flush with the existing gear. And on the front side it may be inset just a tiny amount, but it looks like it's little or no inset there, so I think it'll be fine. Alright, let's do one more pass. This one's a little deeper, probably about 1/1000th of an inch. I like this downward view so I can tell when I'm coming up on the shaft. You can't really tell from this view. Then I can fine-tune by hand here, just moving it in a very small increments. And I can kind of feel when it hits the shaft, it's harder material and it starts rubbing a little bit. And I can feel that vibration through the hand wheel. Alright, that's looking good. You can see that patch really blends in pretty well now. That's the way I wanted to get it. Blow a little air on there. Okay, that's looking very good. I'm going to stop there, but I am going to do one more operation. I'll just take some very fine grit, wet dry sandpaper and clean up that shaft a little bit. Alright, well here we are after cleaning up the patch on the lathe, and I'm very happy with that. In all honesty, it turned out better than I expected. So I'm pleased with that result. So on this back side here, the other side, there's a tiny sliver of solder there, but certainly not going to hurt anything. Purely cosmetic, and I doubt that anybody's going to be looking there for another 100 years. Next operation, I'm going to do a turning operation on the outside of the gear teeth, and the objective is to trim off this excess material from the plug so that the top of the plug is at the same radius as the tops of the existing teeth. So I'm taking off about 3/1000ths at a pass, which will reduce the diameter by 6/1000ths. I don't want to take any deeper than that for fear of knocking something loose. I'm actually using power feed on the slowest setting. I can see some shininess appearing there. That's on the plug, but I don't think I have yet started to touch the tops of the teeth. And I don't really want to remove any material from the teeth. So let's see if I can estimate how close we are here. I don't have a whole lot of clearance behind the gear. I've done this type of work a lot. You know, I'm very confident with the way I have things set up here that I can control that. Now we're ready to cut some teeth in this patch. And when I first started this project, I thought I would need a cutting tool shaped like the inverse of a tooth. But since that would have a sort of concave shape, it would be very difficult to grind, probably impossible with the capabilities that I have. So I decided that what I would do instead is not cut the teeth per se, but to cut the space in between the teeth. Let's take a look now at the process I use for making the tool for cutting the gear teeth. This is just a standard high-speed steel tool blank. It's 1/8 inch square, so it's much smaller than you probably typically are used to using. But I use these quite a lot for special purposes like this. And they're 2.5 inches long roughly. And you can buy them from LMS or many other sources on the internet. But for this job I want shorter pieces. So I first cut this 2.5 inch long piece into 3 sections using a cutoff tool and a Dremel. That leaves me with 3 pieces about this length to work with, and then I can manipulate those to get the shape I want on the end. Here's the setup I use for cutting off the little tool bits. So I've got this special mount I made for the Dremel tool that mounts in the quick change tool post, and I have the tool bit, which is 1/8 inch square, mounted in the 3-jaw chuck, which obviously isn't optimal, but it holds well enough for this job. It doesn't matter if it's not exactly on center, because I'm just going to cut it off. And I'm going to cut off 3 sections of 21 millimeters. 2 other things I wanted to mention. You should wear a respirator. You get this fine metal dust and particles from this abrasive cutoff tool flying into the air. and they're very minute, but you can breathe them in, and I'm pretty sure they're not good for your lungs. So I'm going to get my respirator on. And the second thing is I use a rag down here on the ways of the lathe to keep the abrasive particles from getting down here. If you get them on the ways and you leave them there, they can cause excessive wear on the lathe. I like to turn the lathe spindle on slowly so that the cut cuts all the way around. It seems to do a little bit better job than if I just cut in from one side. And of course you want to allow a minute or two before picking up this cutoff. It'll be extremely hot when it first falls off. That leaves me with 3 pieces about this length to work with, and then I can manipulate those to get the shape I want on the end. There's not much to hold on to, and if you were trying to hold it like this while grinding it, you might injure yourself or lose your grip on the tool blank and have it go flying off to some inaccessible location in the shop. To solve that problem, I made this specialized holder, and it's just made from some 3/8 inch key stock. It milled on the mini mill, cut a slot in it, and drilled and tapped some little holes. And then I can hold this and manipulate the tooling on the grindstone without getting my fingers ground down or getting burned from the hot steel. So this tool is one that I'm getting ready to use to cut the teeth, but it's not yet in its final form. So this is how I ground it down on the 8-inch grinder, and it's pretty close, but I just don't have enough fine control on the big grinder to do the final stages. So I have a little grindstone set up in the Dremel over on the lathe, and we're going to do the work over there. There's not enough room to get the video camera over where I'm working. I have a very small space to get this work done, and so once again you'll be looking at the view that I see on the lathe cam, the overhead lathe cam. But in this case I'm not actually going to be working from that image. I'm going to actually be using some magnifiers and visually looking at the work to do the grinding. I found it's too difficult to use the lathe cam to judge the position of the tool blank against the grinder. It's going to be hard for me to keep it in focus because what's in focus for you may not be the ideal position for me. So let me see if I can tweak the focus a little bit here, and I hope that'll work. But if it's not in focus, I apologize, but at least you understand what I'm dealing with here. So I'm actually using a pair of magnifying safety glasses along with some magnifiers. So I've got quite a lot of optical magnification going, and also good eye protection because I'll be working very close, within a few inches of the Dremel spindle. I need to stop periodically and compare the profile of the tool with the gear itself to make sure that I'm getting the shape that I need. So here's the little gear that this is actually going to be cutting on that section of the blank right there. We're going to cut 2 teeth in that space, and we're also going to have to reshape the edges of the 2 teeth on the other side of it. What I'm trying to do here is grind this tool to the profile of that space between 2 teeth. So I'm going to keep working at it until I get it pretty close. Here's where we ended up. I think this is probably about as good as I'm going to get it. So we've got a reasonably good fit there, I think. Well, this should be interesting. I need to put this little brass plug down in this hole here to protect the gear shaft so that the set screw does not damage the shaft. But I need to make it a little smaller diameter. Well, since this is a really small workpiece that I need to cut off here, I decided I'd better go to a smaller tool. And fortunately, I had made some time ago an adapter for holding 1/8 inch tool blanks in the mini lathe. So it's actually just milled out of aluminum, and it has a slot for the tool bit and then a cover to clamp it down. And the slot is a little less deep than the tool is tall, so that the top clamps down. So now I got to line that up and see if I can shave off a very small disc. First I want to face it. I use a cutoff type tool to do the facing, but I just want to get that little nub off the end left over from where I cut off the previous piece. Got my little brass plug here. It ended up with this stalk on it, which is a convenient way to hold it with the tweezers. And we'll see if we can drop it down in this hole here. I think it flipped upside down. Kind of tricky to manipulate. See if I can get it back out. Put it down here. Get a new grip on it. Drop it in there. See if we can keep it upright. I really couldn't see it very well, so I brought it over here by the stereo microscope, and with just 5x magnification I should be able to see it pretty well. I'm looking through the stereo microscope now and I can see much better. I actually have a really good view here. So I need to grab this little disc. We'll pull it back out and set it up on top here. And now I should be able to drop it down in there. Looks good. It's seated in there. The gear's seated back. Now we do have a problem, or we may have a problem, with that stalk. But my theory was that if I just put the screw in place, it will sort of crush that stalk and everything will work out fine, right? Let's try it and see. Just for fun, I thought it might be interesting to show you what it looks like from my point of view looking through the stereo microscope. Every movement here is very critical because tiny movements, are highly magnified. But you can see right down into the hole there. So we're up at about, I don't know, close to 20 power magnification right now. It's hard to keep the tiny lens of the camera focused over the lens of the microscope. The distance is very critical and the centering is very critical. But anyway, when you're doing it with your eye, it's not quite as critical. But you can see down in there, I can reach down with these tweezers and manipulate the part. But now what I see, of course, is stereo, so it's a lot easier to tell what's going on because you have the binocular view. Now I'm going to try to put this little screw down in there, cap head screw. So 3mm by 0.5 stainless steel. Okay, well, with a little more work under the microscope, I got the screw engaged and squeezed down on that little stalk on the brass plug, and it looks like everything is secure and snug now. So the gear is held tightly in place, and the brass plug hopefully will protect the shaft of the gear from any gouging or damage. Testing to make sure the cutter's aligned with the gear teeth. Now we'll rotate it by 20 degrees. Well, let's bring it around.